Hello class, we're going to be learning two lessons today, lesson 2-6 and 2-7 in your textbooks. And they're very similar, which is why we're doing them together. They're about how to write ratios and proportions, and then how to solve proportions using cross products. So first, let's talk about and review what a ratio is. Okay, a ratio is comparing two different quantities using division. Okay, so a ratio uses division to compare two different quantities. I guess you could do it over here. Okay. And there's actually several different forms. If we're going to write it where it looks like we're dividing two different things, we would write it similar to a fraction. So that's one form. I could write it with words and say A to B. And another format you might see is simply having a colon right in between those two quantities. So things that you need to remember, though, whenever you're writing a ratio, is that ratios need to be written in simplest form. And also, I want you to remember that B cannot equal 0, because when I write it as a fraction in that form, I know that I cannot have a fraction with the number 0 on the bottom. Okay, so those are just some things to remember. So let's look at an example that I wrote. I wrote here that Eric and Evan are going to combine their video games. Okay, Eric has 44 games, let's say, and Evan has 52 games. I really don't know how many they have. So for our first part, I want us to just simply compare the number of Eric's games to the number of Evan's games. So I can say 44 for Eric over 52 games for Evan. Okay, that's one way that I could write it. Or I could write it as 44 to 52, or with the colon, 44 to 52. But you still need to end your answer writing the ratio in simplest form, which means I need to reduce this. I can divide both of these by 4. And so when I do that, on the top I have 11, and on the bottom I have 13. So the ratio of Eric's to Evan's games are 11 to 13. And that's my final answer. For my second part, I want you to compare the number of Eric's games to the total number of their combined games. So again, Eric has 44 games, but when you combine both of them, they have 96 games total. So again, I think I'm going to simplify this by dividing top and bottom by 4. And the top is 11, and the bottom is the number 24. So Eric has basically 11 games for every 24 games. That's the ratio. And again, you could write this as 11 to 24, or with a colon in between those two numbers. So there's different formats. I like writing it with a fraction, but that's completely up to you unless it specifies. So now let's just talk about what a proportion is. Okay, you've heard the word before. So let's just kind of review what it is. A proportion is an equation. And on either side of the equation, you have two different ratios. So it's an equation that says two ratios are equal. So in general, I would probably normally write it as A over B as my first quantity would be equal to something else, C over D. Again, you just have to remember that B and also D, because they're the denominators, that those cannot equal 0. Okay? So let me show you an example of the proportions you're going to be dealing with today. It's going to give you a proportion and ask you to solve it. This one says 11/6 is equal 2x over 30. So the way that we're going to solve this proportion is similar to other equations that you've solved before. You want to get x by itself. So in this case, there's no lonely numbers, but I do have x divided by 30. So I'm just going to simply multiply both sides by 30. Rewrite what I have. I have x on the right side. 30 times 11 is 330 divided by 6. So one more step. Divide those two numbers, and I'm going to find that x is equal to 55. All right, let's go ahead and just check our work real fast. 11 over 6, is that equal to, question mark, 55 over 30? Okay, well they don't look like they're equal, but this just means that I need to reduce. So I think I can divide both of these by 5. That's a common number. So let's check this out again. 55 divided by 5 is 11. 30 divided by 5 is 6. So yes, I did find the right answer for x. Okay. Now, you can also solve a proportion using cross products. That's what we're going to fill in right here. Cross products. This is going to be a really, really good technique to use when you have a variable in the denominator. So in our example here, the variable was on top, right, in the numerator. So I only had one step, and that was to get rid of the 30. But when it's in the denominator, it's kind of hard to do that, which is why we use cross products. So in this case, I have 8 over x is equal to 6 over 15. So when we do cross products, we're going to multiply going diagonally, and it's going to make a cross going straight across like so. So on this left-hand side, I'm going to multiply 8 times 15. And on the right-hand side, I'm going to multiply x times 6. Okay, so let's rewrite this. 8 times 15, that's 120, is equal to 6x. I'm just going to reverse the order there. One more step, divide both sides by 6. And x, we find, is equal to 20. Let's check our work real fast again. 8 divided by 20, is that equal to 6 over 15? Now this is where you really need to check both sides, okay? If I'm going to simplify 8 over 20, let's divide those. I can divide them both by 4, right? So now I have 2 over 5. And on the other side, I have 6 over 15. And you might be thinking, okay, they're not equal to one another, but we got to remember any ratio we need to try to reduce. So we need to try to reduce the right-hand side as well. 6 and 15, I can divide both of them by 3. And now I find 6 divided by 3 is 2, and 15 divided by 3 is 5. They do equal one another on both sides. Okay, let's do one more example. This one is a little bit more difficult, but not much. This one is a proportion that actually has variables on the bottom of both sides. So again, when you do this, you're going to do your cross product. Okay. So on this left-hand side, it's going to be 3 times x minus 6. The most important thing you need to remember is that this is the quantity x minus 6. Some people only multiply the 3 times the x, but it's multiplied by that whole denominator. And the other side is 2 times x. Okay, so now I'm going to use the distributive property to get rid of the parentheses. So 3 times x is 3x, minus 3 times 6, which is 18, is equal to 2x. Okay, let's combine my variables. I'm going to subtract 2x on both sides. And I have 1x minus 18 is equal to 0. Then I'm going to add 18 to both sides. And I can see that x is equal to 18. Let's just check this out one more time to make sure that we got it right. 3 divided by 18, is that equal to 2 divided by 18 minus 6? So 3 over 18, I can reduce that to 1/6, right? If I divide top and bottom by the number 3. And then let's simplify this over here. This is really 2 over 12. And here I can divide top and bottom both by 2. So yes, I got 1/6 on the left and 1/6 on the right. I did find the correct solution. So the last thing that we're going to cover in today's lesson is very similar to ratios and proportions, and it's dealing with scale drawings or scale models. We're going to do an example with a scale drawing, but what I want you to realize is the definition of a scale drawing. What is that? Well, you're picturing like a map, okay, or a diagram. So it's a two-dimensional, I'm going to put just 2D, drawing of a real object to scale. So it's not just like a kindergartner trying to draw the state of California. It's a drawing that's very, very well done. It's just to scale. And similar to a scale model, this is something that you might do if you're going to make a model of a mission. Okay, it's a three-dimensional model of a real object to scale. So the example that I have is a little map here. I love Maui. I've gone there twice now. And on the map, we're just going to say that the distance between two different towns on the island is measured 4.2 centimeters. Okay, this is when I took out a ruler and I measured it on the map. And I want you to find the actual distance between the two towns. Okay? So what you notice on a lot of maps is right in the corner. Might be in a bottom corner, top corner, but they're going to give you the scale of their map. And every map is going to be completely different. But in this scale, they said that 1 centimeter on the map in real life is 85 meters. So that's where I'm going to start, is by writing my scale. So 1 centimeter over 8 meters. Okay? And what I'm looking for is the actual distance. So this on top is the scale, and this on the bottom is the distance. Maybe I should put actual. Let's scrap that out. Actual. Okay? So let's try to remember that the scale's on the top and the actual's on the bottom. So when I measured it with my ruler, I found on the scale it was 4.2 centimeters. But I don't know what it is in real life, which is why I'm putting an X there for the actual distance. So I've set up our proportion. I'm going to do some cross multiplication. Okay, we find that X is equal to 8 times 4.2. I'm sorry, I don't know why I have an 8 there. That should be an 85. 85 times 4.2. Thought that looked a little too small. And then I can find, when I multiply those, that I'm going to get 357 meters. That's the real distance in real life. So if you're wondering how far apart those two towns are, you just solved it. So to finish us off on your own, I have one proportion for you. M over 5 is equal to m minus 6 divided by 4. And I want you to solve this, and I also want you to check it, and then we'll see what you get when you come back to class.